Good morning, everyone. I'd like to start by acknowledging all the people who contributed to this presentation and the assessment work in Toronto. The assessment in Toronto was a lot of effort and certainly would not have been possible without important contributions from my colleagues at Fisheries and Oceans Canada, the Ontario Ministry of Northern Development, Mines, Natural Resources and Forestry, and the Toronto Region Conservation Authority. I'm not going to spend a lot of time talking about AOCs, but since their listing in 1987, there's been considerable progress within the Great Lakes Basin, with 26 of the 43 AOCs remaining with impairments. The focus today is primarily on the Toronto and region area of concern and the recent assessments of fish populations. However, I'll touch briefly on the planned assessment for fish populations in Hamilton Harbour. Historically, both Toronto and Hamilton Harbour supported a diverse and productive fishery, but the loss of aquatic habitat combined with degraded water and sediment quality resulted in both areas being listed as areas of concern in 1987. By comparing historic maps and more recent satellite images, we can see some of these changes. In Toronto, we can see the Ashbridges Bay Marsh, which was a 500-hectare wetland, which was drained and filled and has represented a significant loss of fish habitat in the area. While the creation of the Tommy Thompson Park, or Leslie Street Spit, shown down here, represented an infill as well, it also provided considerable aquatic habitat, and there's been remediation efforts there to provide important sheltered and more warm water habitat for many fish species in the area of concern. Similarly, in Hamilton, along the south shore, there was considerable infilling of the nearshore areas and tributaries, as can be seen here in some historical maps, that has led to a net decline in fish habitat. While the south shore remains to this day industrialized, there are also issues with excess nutrients from 3 sewage treatment plants that contribute to persistent eutrophication, as well as seasonal anoxia. Both factors provide considerable challenges for fishes therein. Focusing on Toronto, we had 3 delisting criteria to guide our assessment, and I'll discuss these more in detail later. But first I'll talk briefly about the types of data we're able to use to inform the assessment. The Toronto Region Conservation Authority have a long-term electrofishing data set that dates back to the late 1980s, both in the harbour as well as for the open coast sections of the area of concern that are prevalent both to the east and west of the harbour. And that's what that top right map is showing. Here's where you can see that we actually took an ecotype-based approach that we used to combine transects together based on whether they occurred in embayments, estuaries or rivers, open coast areas, or slips where it was deeper and more armoured. We also narrowed down a little further as well to look at more specific regional changes to identify whether areas around the central waterfront of the Toronto area of concern were maybe changing at a different rate or in different capacities as other regions. And from this data set, we get lots of information on the types of species present, as well as we can look at trends through time within the AOC and other areas that have comparable data sets. The Ontario Ministry of Northern Development, Mines, Natural Resources and Forestry have used trap nets to sample the AOC biannually, with data records going back to the early 2000s. This dataset provides similar but complementary information as the electrofishing dataset, with the added benefit that other sites in Lake Ontario are sampled with the same protocol. So there's strong reference information for this dataset. The last dataset used split beam hydroacoustics to estimate the density of prey fishes along depth contours. We were somewhat limited in the data in that we did not have ideal reference areas. However, we were able to compare conditions in the Toronto area of concern with those in Hamilton, as well as select open coast areas in the lake. So with both the electrofishing and trap netting data, we can use them to derive an index of biotic integrity, which can then facilitate comparison of condition of fish communities more readily, both within the area of concern and also compared to regional reference areas. So this, just briefly, it takes the general fish catch information, you devise these community metrics, which are also useful for our assessment, and then ultimately you land on an IBI score that ranges from 0 to 100, with low values indicating impairment. So just with that really brief background, here's how we use these data to assess the status of populations. So we use multiple lines of evidence for the first criteria, FP1, which is seeking improvements in community structure, whereas we were more limited in our assessments in the types of data we use for FP2 and FP3. So I'll step through each of these elements and present some selected results. So from the electrofishing data set, we derived a variety of community metrics that are shown here in the table on the left. And from these, we had expected temporal responses that we would think would indicate improvements in the community. So increasing IBI scores, increasing catch of native fishes, for example. We conducted these analyses both within the different ecotypes and also within the targeted ecotype regions of the AOC, but generally here I'm showing the overall patterns. And we found little evidence for changes in most metrics, and where we did see a change, it tended to be the opposite of what we'd expect if conditions were improving. So here the figure is showing a declining trend in total catch at embayment ecotypes in particular, but this general pattern did hold across ecotypes. And so moving over to the right table, here we're looking at comparisons to other areas in Lake Ontario, and relative to the one location where we had similar data, we see that metric scores are lower, and with only the proportion of top predators meeting one of our RAP targets, which is of having that value of over 20%. So from this data set, we conclude that there is still evidence of impairment. Shifting over to the TrapNet database, we saw a little change in IBI scores through time, and that's what's shown here on the left figure. And this was similar for other community metrics, such as the proportion of top predators. And comparing more regionally, and again, we see lower IBI scores within the area of concern compared to two comparable areas in eastern Lake Ontario. So once again, similar to the electrofishing database, we see continued evidence of community impairment here. Finally, the last element of FP1 used the hydroacoustics data, and if you look within the AOC, which is the bottom left figure, we see higher densities of prey fish in the more protected inner and outer harbors compared to the open coast areas, suggesting variation among our ecotypes. And if we shift to the regional data, both the open coast and embayment areas within the AOC had comparable or higher fish densities compared to the more limited suite of reference sites that we had sampled in the Western Basin. So based on these results, we found no evidence of impairment based on this line of evidence. Shifting to the species-specific assessment of FP2, we focused solely on trends through time for the electrofishing dataset, which had the longest time series. And since some species of interest were captured infrequently, we first looked at encounter rates, so the presence and absence of a species in our catch, and if there was sufficient data, we also then tracked species abundance. And similar to the community metrics, we developed some desired responses for these trends and evaluated both within the ecotypes and within the ecotype regions. In general, there were either no apparent trends or the trends were counter to our desired response. For example, the figures at the top show a declining trend in northern pike catch at a specific region, which is the embayments in the Toronto Islands. Well, not surprisingly, in the middle figure, we see the probability of capturing round goby in embayments in general increased rapidly in the early 2000s before stabilizing. And finally, the figure on the right, again, in the embayments in the Toronto Islands region, we see largemouth bass initially showing a positive increasing trend into the 2000s, but this leveled off or declined more recently, resulting in no net change for the species. So collectively, the absence of these desirable trends for our focal species were indicative of residual impairment for this criteria. Finally, watershed urbanization can alter stream habitat, which can decrease fish species richness. And for the final FP3, the Toronto Region Conservation Authority has developed an integrated restoration prioritization tool, or IRP tool. And the tool can be used to identify opportunities for restoration and also priority areas in need of restoration. And so for fish, this may include the removal of barriers within a watershed to passage, so dams and whatnot, improvements to water quality, or actions that can be taken to reduce water temperatures, such as planting and riparian zones. So the figure is showing, across the watersheds of the Toronto Region area of concern, areas in red are high priority, so lots of opportunities and in need of remediation, whereas in contrast, areas in green have less impairment and are therefore maybe are good candidates for protection. And so based on the availability of this tool, we think this criteria is complete for the fish population, since it can be used to help support watershed plans. So piecing it all together from the various lines of evidence for these delisting criteria, we conclude that there was continued evidence of impairment, and the recommendation from this current assessment is that the fish population BOI remain listed as impaired for the Toronto Region area of concern. So from this assessment, a variety of recommended actions emerged, and that included things like continuing to protect and remediate habitat within the AOC, since habitat availability is thought to be one of the main limitations for increasing species abundance. However, given the current extent of development within the area of concern, there's limited waterfront opportunities for new habitat creation. There's also a need to continue to manage non-native species, since we do not see any declines in their abundance. So continued use of passive barriers to control common carp and any active control measures that may be suitable could help to reduce these populations. And last is just maintaining the provincially led walleye stocking program will hopefully support the recovery of the species in particular. So in Hamilton Harbour, a similar stocking program has been quite successful, and stocking efforts in Toronto are well underway, with hopes to see increasing abundance of walleye in the near future. So we will revisit this assessment after the completion of the Don River Revitalization Project, which will ultimately yield substantial habitat gains in the waterfront and likely represents the last opportunity for large-scale habitat creation. And for this future assessment, we identified a variety of key elements that should be included. And most importantly, it's exploring whether the long-term trends we did see in species and metrics within the Toronto area of concern are also present in other long-term Lake Ontario data sets. And this will help us determine whether these trends are AOC specific or maybe part of a more regional or lake-wide pattern. So shifting now quickly and just briefly to Hamilton Harbour and that area of concern. The assessment for populations will occur over the next year, and here we have delisting targets with specific species that are listed, as well as the target ranges for IBI scores. We will have comparable data sources in Hamilton, including the trap netting and hydroacoustics that we talked about earlier for Toronto, as well as a long-term electrofishing database that DFO has maintained since 1988. And we again plan on using a similar approach as Toronto to look at trends through time, as well as regional comparisons for specific species in IBI and other metrics. Additionally, we have acoustic telemetry in Hamilton Harbour that will be used to help identify potential actions that may support population recovery. And we're working now with those data to try to determine local habitat use by some target species. The system still has lots of challenges, specifically anoxia during the summer, as well as eutrophication. But the assessment will set our current status for the population and hopefully reveal some measures that could be taken to help improve the fish community. So this figure here is showing those lines of evidence once again, and how they then tie into the different FP or criteria. So based on the recommendation from the Toronto assessment that we should explore trends in other data sets, I just wanted to show some very new results for analyses that were completed just last week. And here we're comparing fish community composition and changes through time among Hamilton, Toronto, and the Bay of Quinte. And in the Bay of Quinte, fish populations have been delisted. And as such, having fish communities in Hamilton and Toronto become more similar to the Bay of Quinte may be desirable in achieving our objectives. So for this analysis, however, the results are suggesting that while the Bay of Quinte has remained largely stable through time, shown here in the yellow line, communities in Toronto along axis 1 and in Hamilton along axis 2 have changed considerably over the time period. While additional analyses of these data is suggesting that Hamilton and Toronto communities are converging towards the Bay of Quinte, they still remain quite distinct. And so as a next step, we're going to begin to identify the specific species that are driving these observed trends. And overall, it's a pretty exciting type of analysis, and with these additional results and interpretations to come, hopefully over the next year. I think that wraps everything up today, so thank you so much for taking the time to listen to the talk, and I'd be happy to answer any questions you may have.